Hello बच्चों, let's read this question. So the question says a particle of charge equal to that of an electron and mass 208 times the mass of electron moves in a circular orbit around a nucleus of charge plus 3e. Assuming that Bohr model of the atom is applicable to the system, derive an expression for the radius of the nth Bohr orbit. Find the value of n for which the radius of the orbit is approximately the same as that of first Bohr orbit for the hydrogen atom, and C. Find the wavelength of the radiation emitted when the revolving particle jumps from the third orbit to the first. So we have to solve this question, and the key concept here is electromagnetic radiation. So there are two key concepts: Bohr's model of atom, and along with that we have electromagnetic radiations. All right, so let us solve this question. Now we know that जो रेडियस होता है, रेडियस ऑफ nth ऑर्बिट फॉर हाइड्रोजन एटम, रेडियस ऑफ nth ऑर्बिट फॉर हाइड्रोजन लाइक एटम is given by RH is equal to n square h square divided by 4 pi square k me square z, k me square z. बट यहाँ पर क्या हो रहा है, हम m को रिप्लेस कर रहे हैं 208 मल्टीप्लाइड बाई m में, एंड z को रिप्लेस कर रहे हैं 3 into z में, right? So r dash will be n square h square divided by 4 pi square k, m के बदले हम पुट करेंगे 208 m मल्टीप्लाइड बाई e square मल्टीप्लाइड बाई z के बदले हम पुट करेंगे 3z. Alright, so z will be just plus 3 because यहाँ पर z is equal to plus 3 electrons बताया हुआ है, so z will be plus 3. So this is equal to n square h square divided by 4 multiplied by 208 multiplied by 3, that is equal to 2496. 2496 pi square k me square. This is the expression of radius for nth Bohr orbit of this particle. Alright, now so ये हो गया answer for A. Now for B we have to find the value of n for which the radius of orbit is approximately same as the first Bohr orbit of hydrogen atom. Now for H atom, the radius of first Bohr orbit suppose r1, तो हमें इस एक्सप्रेशन को देखना पड़ेगा, RH is equal to n square z square by 4 pi square k me square z, and for first Bohr orbit n is equal to 1 and for hydrogen z is equal to 1, so this is h square divided by 4 pi square k, so here comes k me square, and for this particle we found out that r dash is equal to n square h square divided by 2496 pi square k me square, pi square k me square. Now इन दोनों को हमें इक्वेट करके देखना पड़ेगा कि n की वैल्यू कितनी होती है, so that we get both of them same. So h square divided by 4 pi square k me square is equal to n square h square divided by 2496 multiplied by पाई स्क्वायर के एम स्क्वायर। सो यहाँ से एम स्क्वायर और एम स्क्वायर कैंसिल हो गया, के और के भी कैंसिल हो गया, एंड पाई स्क्वायर आर ऑल्सो कैंसिल्ड। यहाँ से एच स्क्वायर एंड एच स्क्वायर आर ऑल्सो कैंसिल्ड। सो 4 and 2496 can be cancelled, and we have over here 624. So here n square is equal to 624, और अगर हम स्क्वायर रूट लेंगे तो n is almost equal to 25. So at n is equal to 25, the radius of orbit of this particle will be approximately same as the first Bohr orbit of hydrogen atom. Now let us find out the wavelength of radiation emitted for revolving the particle that jumps from third orbit to the first orbit. Alright, so here we have nu bar is equal to RH multiplied by z square multiplied by 1 by 1 square minus 1 by 3 square. Alright, here RH will be different, so we have to put a different value of RH, so let it be R dash. और अगर हम R dash की value calculate करें, then we know Rayburg's constant is given as R is equal to 2 pi square k square e fourth m divided by ch cube, और यहाँ पर हम m को रिप्लेस करेंगे 208 multiplied by m में. So r dash will be 2 pi square k square e to the power 4 multiplied by m multiplied by 208 divided by ch cube. So this is equal to RH multiplied by 208. Alright, so this is the value of r dash. Alright, so r dash is RH multiplied by 208. So this is RH multiplied by 208 multiplied by z square, that is 3 square multiplied by 1 minus 1 by 9. So this is equal to RH की वैल्यू हमें पता है 1096780 meter inverse multiplied by 208 multiplied by 9 multiplied by 1 minus 1 by 9 is 8 by 9. So 9 और 9 cancel हो गए, and we have 1096780 meter inverse multiplied by 208 multiplied by 8, and we have to take the wavelength. So here we have wave number which is equal to 1 by wavelength. So wavelength is 1 divided by 1096780 into 208 multiplied by 8. So this value is equal to 5.48 multiplied by 10 raised to the power minus 11 मीटर, जिसको कि हम लिख सकते हैं 54.8 इंटू 10 रेज टू द पावर माइनस 12 मीटर और 54.8 picometer. So wavelength of radiation is 54.8 picometer. This is the required answer, and I hope you understood the concept well. Best of luck.